Most programming languages have the ability to store unordered collections of data, where you can randomly access items in the collection by their keys. In some languages, these are known as associative arrays, in others, structures. But they always serve the same purpose, an unordered collection of data where you can get to one item at a time. In Java, we do this with a class called the hashmap. Just like the array list, it's a class, and when you declare it, you have to import it. I'll start in this empty main method in the project hashmap, and I'll declare an instance of the hashmap class. I'll type in the name of the class and press Control Space. Eclipse recognizes that this class must be imported, and it adds the import at the top of the code. Just as with the array list, the hashmap is designed to store data all of the same type, but where the array list needs one data type, the hashmap needs two. Each item in a hashmap will have a key and a value. Notice that these are represented in the diamond operator, that is where the generic is declared, using the letters K and V. In some languages, the key always has to be a string, but in Java you can really use any object. For simplicity though in this exercise, I'll declare both my keys and my values to be strings. So I'll type in string, press tab, and type string again. And then I'll declare the variable name, map. Next I'll instantiate the class. I'll type in the code equals new. Then once again I'll type the name of the class and press Control Space. There are 4 different versions of the constructor method for hashmap. There's one with no arguments, there's one with an initial capacity, and there are a couple that let you initialize the object in other ways. I'm going to choose the simplest one, the one with no arguments. Eclipse looks at my original declaration and matches my constructor method call. Now the code's getting a little wide, so I'll maximize my editor. I'll add the semicolon at the end of the line, and now I've created my first hashmap. In order to add items to the hashmap, use the method named put. I'll call map.put, and I'll see that there's only one version of the put method. It requires 2 values, in this case 2 strings. And once again using the names of states, I'm going to use the name of the state as the key and its capital as the value. So I'll type in California, then tab over, and type in Sacramento. I'll add another item to the map. This will have a state name of Oregon and a capital of Salem, and finally I'll add Washington and Olympia. Now I'd like to output the contents of the map to the command line. Just as with the array list, the hashmap has a 2-string method that will serialize its contents so it's easy to read. So I'll use system.out.println and just pass in the map object. I'll save and run my application, and there's the results. Each item contains a key and a value, separated by the equals operator, and the entire list is wrapped in curly braces. Just as with array lists, hash maps are resizable at runtime. So I'll add in yet another state, Alaska, and its capital, Juneau. And I'll copy and paste my print line command. I'll organize my code so that it's all grouped together correctly. And I'll run the application, and there you see that I'm successfully adding an item. You can find an item in a map by referring to the key. So for example, let's say that I wanted to find the capital of Oregon. I'll declare a string variable, I'll call it cap, and I'll call map.get, and I'll pass in the key, Oregon. And then I'll use a print line command, and I'll say the capital of Oregon is, and I'll output the value of cap. And I'll run the code, and I get the capital of Oregon is Salem. That's correct. Now once again, as I mentioned, this second item in the hash map does not have to be a string. It could be any kind of complex object. And as you get into creating your own custom classes that represent data, you'll find that hash maps are very useful for storing large collections of data in memory. Next, I'm going to remove an item. With the array list, you removed an item by its index position. But remember, a hash map isn't in any particular order. So if you want to remove an item, you refer to its key. So I'll call map.remove, and I'll pass in California, and I'll print out the map, and I've removed California, and I'm left with the 3 remaining states. Take a look at the documentation for the hashmap class to learn more about it. I'll select the name of the class and go to Dynamic Help, click for the Java doc and Maximize, and go to the method list. You'll see that there are methods to determine whether a particular item is available in the list. Those methods are named contains key and contains value. There's a method for determining whether the hash map is empty. It's called isEmpty and returns a Boolean. There's put methods, a put all method, size methods, and values methods. I'll show you how to use a couple of these other methods in a later video when I show you how to loop through the hash map using something called an iterator object. But this should give you enough information to get started with hash maps, storing unordered data collections in your Java applications.